Today we're going to be presenting about our smart greenhouse, and we are from group 16.
So the first one is to define the component of the Arduino. The first one is define fan V3 is for the pin vent fan. Second one is the pin 4 is for the water pump. Next one is to define rain pan A3 is for the rain sensor, which is this. Next one is rain warning pin is for LED and also the buzzer. Next one is define temperature TDC is for the temperature sensor. After that is for the soil moisture pin is for the soil moisture sensor. Next one is define humidity pin is for the humidity monitoring. After that is the on-off switch pin is for the on-off switch of the Arduino. The next one is the define buzzer pin 8 is for the buzzer. Lastly is the servo vent servo. It's the create servo object for the vent.
Assalamualaikum, my name is Asyraf, and now I would like to talk about the coding for the sensor data collections. For the first part, which is this part, if the sensor value is equal to 0, which is the minimum value, or the sensor value is equals to 1023, which is the maximum value, it's indicate that the sensor was fault. Like the sensor do not connect properly, or even the short circuit. So the buzzer will trigger that show that the sensor are fault. So let's move to the temperature sensor. So the maximum for threshold temperature is 16. So if the temperature is over than 60 degree, it will make the buzzer to trigger. So let's me show. So if let's say we do a 41 degree Celsius, the buzzer will not be triggered. But if we do over than 60, the buzzer will trigger. So now let's move to the soil moisture sensor. For this part, if the soil moisture value is equal to 0, the buzzer will trigger. Why? Because the soil moisture value is equal to 0. It's almost impossible in the real life. So in this coding, how we it happens. So let's say if the soil moisture is 0, the buzzer will trigger. But if we up the moisture, the buzzer will no longer trigger. So let's move to the last sensor in this part is the humidity sensor. In this part, if the humidity is equals to 1023, which is the maximum value, the buzzer will trigger. For this coding, we can see if we can show if the humidity is full, the buzzer will trigger. But if the humidity is low, the buzzer will not trigger.
I will now explain how control vent and fan and control water pump functions manage the system's ventilation and irrigation based on the sensor data. The vent adjusts its angle based on temperature and humidity. If it is cold and dry, with temperature below 20 degrees Celsius and humidity under 40%, the vent fully closes. If conditions are moderate, which is temperature between 20 degrees Celsius and 30 degrees Celsius, and humidity under 60%, the vent open halfway. If it is hot or humid, temperature above 30 degrees Celsius, or humidity above 60%, the vent fully opens. For any other condition, it defaults to halfway open for balance. For the fan speed part, the fan adjusts its speed based on temperature and humidity. high speed if the temperature is above 30 degrees Celsius or humidity exceeds 60%. Low speed for moderate condition, which is temperature over 30 degrees Celsius or humidity above 40%. Otherwise, the fan turns off to save energy. The water pump will turn on if the soil moisture sensor reading is less than 500. If it is more than 500, it will turn off the water pump. Lastly, in rain detection part, the pump reacts to rain detection first. If rain is detected, the pump turns off to prevent over-watering.
So the next one is the phase shift system. It's for the rain detection. So it's the function to check the rain sensor to see if it's detecting rain. So if rain is detected, a warning signal like a LED is activated to notify user. This for example. If the rain is detected, the LED will activate it. So the function will return to true if rain is detected and false if no rain is detected. So when there is no rain, the LED is back to normal.
Now I'm going to talk about the serial monitor and what will be displayed on it. So if when the system is off, it will print system off in the serial monitor, and when we turn it on, it will say system initialized, and it will print out all the values. It will take values from this sensor, temperature sensor, humidity sensor, moisture, and the rain sensor, and it will print it on the monitor. We can try it to see if it works for 50, 34, and the temperature change, same with the humidity, the soil moisture, and the rain detection. It will say yes if there is rain detected. So there's also another part of this code which is the fault. When it will print fault is when there is a problem with the sensor. For example, uh, temperature reaches more than 60 degrees, humidity becomes zero, and when moisture level becomes zero. As you can see at the code just now, it will say system fault.
So the next one is for the voice setup. Is for the output and input of the Arduino. So the output of this Arduino is the first one is the fan pin. The second one output is the water pump pin. The third one of the output is the rain warning pin, which is the LED and also the buzzer. The lastly the output is the buzzer pin. Uh, the buzzer pin is to activate a buzzer for alert. So the input is the rain sensor pin. And the next one is the on and switch off pin is for the input.
For the void loop, first we turn off the buzzer pin, and then if the switch is turned on like this, we will read the temperature, humidity, and soil moisture value while uh, checking if there is rain or detected or not. Using those values, we will control this vent fan and water pump and the micro server according to the values. And while doing that, we will also display the values on the serial monitor. If the switch is turned off like this, we will make sure the vent fan is off, the servo is closed, the water pump is closed, and the warning LED is closed if it's turned on, and the buzzer turns off. We will also print at the serial motor system off. We will delay this program for 1 second.